dawn of a new horizon for Africa. Eko Atlantic City is a new vision for Lagos, Nigeria. It's named after the sometimes stormy ocean it lives with. A city that's being built on reclaimed land that was lost to over a century of coastal erosion. But even the worst storm Lagos could expect over 1,000 years poses no real threat to the emerging city. It will be safe and secure behind the Great Wall of Lagos. The Great Wall is an 8-kilometer-long revetment to protect Eko Atlantic and low-lying Lagos from the relentless forces of the ocean. It's being constructed to the highest standard of marine engineering available in the world today. An international team of highly skilled coastal and marine engineers applied physical scale model tests and computer simulations in Denmark to assess its stability under the pressure of extreme wave conditions. The design proved itself beyond doubt. It splits into 12 different layers of rock and concrete, which form this massive structure. Most of the Great Wall lies on the seabed, between 7 and 11 meters underwater. This is where its real strength lies. So the base of the Great Wall is around 45 meters, and the depth is typically 18 meters. Construction begins with the scoop of an excavator arm that's carefully controlled from a digger, swinging a gravel-filled shovel into a defined position over the water. It drops a thin spread of material onto the ocean bed at a depth of around 10 meters. This first layer is a filter that prevents sand on the seabed from moving through the structure. The next step focuses on the placement of what's known as the underlayer for the tow berm and provides support for the additional layers that will follow. The essential rock core component is quarried locally. Here, the process of grading rock to appropriate sizes takes place every day. Once sized, the material is loaded onto trucks for transport to the Eko Atlantic development area. This quarry-run core consists of boulders ranging from fist size to 1 ton, providing a stable body for the main structure. On top of the core, yet more rocks, weighing from half a ton to 2 tons in size, are put into place by a highly trained operator using a long-arm excavator. Successful rock placement is pivotal to this work and is guided to an accuracy of 10 centimeters using a global positioning system fixed on board the excavator. This rock underlayer provides a solid foundation for the primary armor that comes next, and also prevents vital core material from moving through the wall and being lost to the open sea. Large 2-ton rocks are positioned on top of the tow berm to further stabilize the wall against attack by both wave action and current. It also provides a secure locking system for the first row of acropods that slope above it. The most visible part of the Great Wall of Lagos is known as the primary armor section. In simple terms, it's like a giant jigsaw puzzle of interlocking X-shaped concrete blocks that are called acropods. Each acropod weighs 5 tons, and Eko Atlantic needs 100,000 of them in all. They're manufactured on site, and every single one of them has to comply with rigorous tests to ensure that the required compressive and tensile strength of all units is maintained before they're loaded and added to the wall piece by piece. Nothing is left to chance. moulded out of a special concrete that eliminates the need for steel reinforcement, they're placed in a predefined XYZ grid, again using a GPS system for pinpoint accuracy. On the land side of the rock core of the wall, the surface must now be smoothed out with granular material, enabling geosynthetic filter fabric or geotextile to be installed. This is another important element in the complex mix of filter layer, rock core and concrete armor blocks that comprise the Great Wall of Lagos. The very durable geotextile is made out of non-woven polyester. This effectively serves as a separation membrane, and also in preventing reclaimed sandfill from escaping the wall structure. But it still allows ground and seawater to pass through the fabric in a controlled fashion. In order to cover and protect the geotextile, sand is placed directly against it. On top of the sand, the geotextile is rolled horizontally to accommodate another foundation layer of rock, which supports the concrete crest element that finally completes the revetment. The Great Wall is now truly taking shape, and its distinctive design rises 6 meters above the surface of the sea at this stage. But there is yet more to build. To further reduce the extent of spray and overtopping onto Eko Atlantic's oceanfront promenade in extreme conditions, the crest element or wave wall rises to 8 meters above sea level. Once the wave wall is complete, this formidable sea defense barrier is again reinforced by a wide sloping layer of rocks ranging from 500 to 2,000 kilos. They support the finishing layer of primary armor units. As sections of the wall are completed, a vast sand layer, upon which the actual city of Eko Atlantic will rise, is laid to a height of around 8 meters above sea level, protected by the revetment. The Great Wall of Lagos is now finished and up to full strength. It will ensure that everyone living and working in the 9 square kilometers of reclaimed land for Eko Atlantic, as well as the population of Victoria Island, are protected from the sea.